Yeah, all right. So yes, you want to put it in that form, right? So I'll just write up that form for those of you who are going, what form? We were talking beforehand. So x minus a squared plus y minus b squared equals r squared, yeah? That's the form you want to get it in. Well done, you. Yeah, you've been away a few. Yeah. Is it counted as skipping if you just don't turn up for the whole day? It's not truanting because, well... Yeah. All right, so yeah, we're going to get it into that form. So what are we going to do? What's the one bit we're going to do first? What are we going to get over to the right-hand side? Yeah. Equals 15. All right. So we've started to get it in that form. We do have a small issue though, don't we? Because we need to get the x's, we need to get that into a set of brackets, don't we? We need x minus a all squared. If you had a look at that, if I just put a bracket around it just for illustrative purposes, is there any way we could factorise that? Because it's not two perfect squares, it's not a difference of two squares, it's not a quadratic as we recognise it, is it? Nah. So we've got this problem where just dragging it across, it's not going to work. We're not going to be able to get it into that form. I agree, we want to get it into that form because that'll tell us what the centre is and that'll tell us what r is. Okay, because we're going to use that to find our centre and we're going to use that to find our radius. So you're absolutely right, that's where we need to get to. The question is, how? Isabel said something earlier. We're going to complete the square. Cool? Now the question is, do you remember how to complete the square? I think there was an eye-rolling episode just a second ago. It's a little bit fuzzy. All right. All right, so we have done the first step. We've moved the constant over to the right-hand side. And yeah, as we just discussed, we have to complete the square. Now, offline, we just talked about what completing the square means. Okay, at the moment, we basically, in essence, have one part of a perfect square, but we don't have the last bit. We have to complete the square. Cool? Now, what we just talked about is when we have a perfect square and we expand it, you square the first, you double the product, then you square the last. Yeah? The bits we're missing are the square the last bit, which is kind of important, and the... Oh, you're not going to rub out for me, are you? Yeah, sure. Good. We are missing the square the last bit, and we've got the double the product, but we've got to use that to find out what our last bit is, which was a really confusing way of saying x squared plus 2x, excuse me, I'm just going to cough for a little bit because it's fun. Sorry?
So you can just look at it.
Yeah, kind of. It's a plus 1 to start off with, but you'll see what I mean by the negative 1 in a minute. Okay, so the bit you're going to add, and I'll just put in the plus y squared minus 6y equals 15, and then I'm just going to change colours. Okay, so what we've got to do is put in the bit that would complete the square. So if you think about when you've expanded it out, you've got x squared plus 2x, what's the number at the end have to be? It has to be 1. Yeah? Because double the product and then square the last. So 1 squared and you got double the product would be 2x. Cool? And then on the other one, you've got the plus y squared minus 6y. What does the bit you've got to add have to be? Has to be negative 3. Okay? So if you really want to look at that closely, you can go, I've halved that and I've halved that, and that gave me them. Is that all right? Works well with monics. Yeah. You all right? There's something else we've got to do because You have to, whatever you do to the left, you're completing the square. So you are manipulating, and that's one of the things we like to do. We like to manipulate equations. But if you do it to the left, you've got that equal sign that says I am balanced. If you do it to the left, you have to do it to the right. Does that make sense? Okay. So we do to the left, we do to the right what we did to the left. Cool? Does that make sense? So we do exactly what we did to the left, to the right. It doesn't matter what you do to the left. As long as you do it to the right, you're all good. Yeah. But I think now that you guys have got a few more tools in the bank, this actually is a bit easier to explain, because you can start to recognize that it's half that when you're doing a perfect square, and the fact that completing a square is actually to do with perfect squares. It's not just some random thing that I told you. Okay. Yeah, well, now you just... Well... Do we? Yes. Yeah. What we're going to do is we're actually going to factorize it so it looks like it should. But you know what A and B are, because you've done A squared there and you've done B squared there. Should I have -3? Should I have a -3? No, I should have a +9. There. Yeah. Yeah. Why should it be a +9? Because I'm squaring it. I wrote down what B will be. Whatever will be. But we needed to square it. Yeah? There was a lot of B's. How many B's do you reckon I said? 2 B's or not 2 B's? That is the question. The look of disdain. It's like, oh, dude. Again, still. All right. So now we've got to factorize it. So, but you know what A and B are realistically. So yeah, what are you going to have? What am I going to have? Which is nice because it's a square number. Okay. So now we have it in our form that we want. So we can go, okay, well, R equals 5. Do we? No, because remember, that's when you square it, you get the 9. That's right, because it's the square, the first square, the last bit. And I screwed up because I just put in the 3. Because the 3 is half of the 6. And that works. Minus. Yeah, all good? Okay, and now we can write down what our centre is. What's our centre? It's a coordinate. Yes, well done. -1 and, yeah. It's like the roots of the equation. It's the opposite of the sign. Because what you've done, if you've gone, here's my x, +1. So to get back to the centre, I have to go -1. All good? Happy with that? That wasn't too fail. That wasn't too painful. So find the radius and the coordinates of the centre of the circle. So we have the radius, we have the coordinates of the centre of the circle. All happy.